Here's an example of proving that square root of 2 is irrational. This is kind of a tricky proof, so bear with me. I'm going to show you the proof, the complete proof, and then we'll justify each step. Okay? The proof is by contradiction, and here's the complete proof. And let's justify it one step at a time. Yeah, so cool. I'm gonna use groups of people to justify each step. How do we justify the first step? People at the back, last row. What's the first? How is the first step justified? First step is just the negation of the conclusion. Yes. Oh. Where are the justifications? Okay, I don't have them on the slides for some reason, but this step is just the negation of the conclusion. Okay. What's the next step? Yeah, it's the definition of the rational numbers. Okay. If square root of 2 is rational, then I can always write it as P over Q, where P and Q are some arbitrary integers in the domain of integers. Okay. With me, if okay, 2 is not equal to 2 does not divide P, or 2 does not divide Q. How do I come up with that? How do I justify this step? Think about it. This takes 30 seconds. Yeah. P and Q आपस में equal नहीं है. Okay, good. ठीक है. Okay, that I agree. But why is it that they are not divisible by 2? So this thing is actually saying that P or Q दोनों odd numbers हैं. Okay. How can I assume that P and Q are odd numbers? What? But see, देखो ये वाली line से पहले वाली जो चीज़ें पढ़ी हुई है ना, वहाँ से आपने निकाल के मुझे बताना है कि why is this line true? क्या? Yes, but it's why is it that, I mean, it could be so. You're actually giving perfectly good arguments, but
second step का को उधर जाकर मल्टीप्लाई कर देंगे तो वो एक डेसिमल वैल्यू आएगी तो वो
क्या? So the thing is, P and Q could be really large numbers. They don't need to be something between 0 and 2. Okay? So just at this point, I'm just saying that P over Q ratio is equal to square root of 2. Doesn't mean that P and Q are small numbers. They could be super large billions of digits, large numbers, right?
So the root 2 is an irrational number.
That we don't know yet. We actually assume that under root of 2 is rational. That's where we started with. Okay, I'm kind of happy with the exercise that we are doing. Okay, so again the question remains, how could I say this thing? I actually said it. I mean, I gave you the justification here. I just want you guys to kind of take it in, take the justification in and see why this is true. Yeah.
Fraction. It's a rational number, it's a fraction. And a fraction is like anything that's not divisible by 2.
Okay. I need a rephrasing of that statement. Yes.
P and Q belongs to the same thing that
P and Q belong to the set of integers. That does not justify that. I mean, even numbers are in the integers, right? So why are P and Q not in even numbers?
Such a simplified form and fraction.
Yes. Okay. So what I'm kind of saying here is that I'm assuming that P and Q are a simple fraction. Okay? If they are not, what I'm saying is, if they are divisible by 2, then I'll divide them by 2. I'll get some other P and Q. Okay? And that P and Q will justify the statement. And if those P and Q or also even, I'll divide both of them by 2. And I would get another P and Q. I'll keep doing this until I get a P and Q which are not both even, okay, or at least one of them is odd, okay. So this is very tricky, but it's used a lot in discrete math. That if you find an example that's not the kind of example that you're looking for, you do something with that example, and that gives you some other example, which is what you're looking for. Okay. So at this point, we're looking for an example of P and Q where at least one of them is an odd number. If they are not, then I can always divide them by 2, and I'll get another P of Q whose ratio is actually equal to square root of 2. Okay. So that's why I can assume at this point. इस चीज़ को के लिए एक वर्ड यूज़ होता है जिसको मैंने यहाँ पे नहीं लिखा. That's called without loss of generality. Okay. I'm writing it on the invisible mirror. So it says without loss of generality. Okay. Don't ask me what this means, but it kind of means that the examples are still general enough. Okay. Generality. Kind of mess spellings at times. Generality. Okay. WLOG, you'll see that. Okay, so now that we are happy with this, that they are not divisible by 2, here's what we are going to do. We're going to square the both of these sides. Okay, this part becomes 2, and this part becomes P square over Q square. Remember, this is proof by contradiction. We assumed square root of 2 to be rational. Okay, so ultimate goal is where do we have to arrive at? What? So we have to arrive at a contradiction. Okay, we are looking for a contradiction. We have to arrive at some point that's opposite of what we just said. Okay. Yes. Okay. Cool. So this step is clear, right? This step is also clear. I just moved K square here. But if this is the case, then 2 divides P, right? If P square is 2 times Q square, then P square is an even number. If P square is an even number, then P is an even number. Alright? Are we good? Okay, so at this point we have proved that P is not an odd number, which means Q must be an odd number. है ना? Yes. ये वाली statement है. I should have numbered them. This is the statement number 2. इसको हमने स्क्वायर किया. हमने इसको स्क्वायर किया. जब हमने डिफाइन किया था, हमने कहा था square root of 2 is irrational number. It must be equal to P over Q. If I square both sides, I'll get 2 square, and I'll get P square over Q square. Okay. And now P square is 2 times Q square, which means that P square is even. If P square is even, then definitely P is even. Okay. Square. अगर आपका square even है तो फिर उसका root है वो भी even होगा. All right. So cool. So we can write P as 2 times K. Okay. So far with me. So if I plug 2 times K in this equation, I would get 2 is equal to 4K square over Q square, and that gives me this statement that Q square is 2 times K square, which means Q is even. Oh, but we just said that they cannot both be even, right? And that's it. We said something, and then we proved that whatever we said is wrong, and we reached a conclusion, which is a contradiction. Are you with me? Yes? Cool. So we started with the assumption that original statement is wrong, square root of Q is rational. If this is rational, we define what rational means. और फिर हमने ये कहा कि since this is the fraction, if both numbers are even, we can simplify it. We can always simplify it. So keep doing it until we reach P or Q. One of them must be odd. Okay, if one of them is odd, let's do the square of the things. If we do the square of things, we could reach the conclusion that P is even, and then we reach the conclusion that Q is even. Okay, but that's not possible, right? We just said one of them has to be odd. So we reach contradiction, and that contradiction proves that our original statement, negation of Q, must be wrong. All right, good. Do you like this proof? Okay. Questions? Complaints? Comments? Yeah? This step? So this step is saying that if P and Q are both even numbers, throw them away. Divide them by 2. If they are both even, you can divide them by 2, right? You get another P and Q. Okay? If this P and Q are both even, throw them away. Keep doing it until you reach a point where one of them is odd. Okay? If you start with 2 even numbers, you keep dividing them until until one of them is not even. Yes.
Why did we throw away the even?
Because we wanted to ultimately prove that both of them needs to be even if they are equal to square root of 2. Okay? That's kind of, this proofs are tricky. You at each step you don't have a set of actual inference rules that you can apply. Okay? It's really hard. You need to figure out. You need to kind of start from a contradiction. How can I reach a contradiction? What can I do with things that will get me to the contradiction? What kind of assumptions can I make? It's very tricky. This is not science. This is arts. Okay? You do things, and when someone in, I don't know, okay, when someone was trying to prove the square root of 2 is irrational, I guess they spent like 6 months doing different kind of proofs until they reached this point, right?